Hi, welcome to a product review by watthour. In this video we are going to do the review of this BULVACK 300 ampere waterproof breaker or switch. It can be used in cars and boat and anywhere that you have high current for ignition protection, for anything that you want to disconnect the battery. You just press this and it will disconnect that up to 300 ampere and easily you can connect it back like this. I'm going to test it with maximum current and see how it behaves, and also I'm going to use thermal camera while the current is passing to see how hot this gets, and all the features will be tested. Let's get started with this. I purchased this from Amazon for 300 ampere. This is $20 US plus some shipping. If you have Prime you might get it for free. Selling it with different ratings. I'll provide you the link below this video if you want to purchase it. Here is the package. They send it like this. I remove the tape. So when you open it, they've included this crimp type connector and these This is not the right way to attach it with these screws. And here, this is the breaker or the switch. So how it works is that you will remove your main cable that was connected in here, remove it, and then connect the breaker like this, the breaker to the battery, and then the wire that was connected there will be connected to this terminal like this. They have cap here and these nuts, but clearly when you see 300 and you see these nuts, this doesn't make sense. How can you even tighten it? From the bottom you cannot hold it. So this is inside the plastic. If you tighten it with a wrench or something, if you press a little, this will just rip off. And underneath we don't know how thick this path for the wire for this one is, but regardless we are going to test it, and that's easy. I needed to disconnect for 100 or 200 ampere that I'm using, and this will make it very easy for me to just disconnect the battery, because it will be very hard to put wires and nuts and bolts to connect it. So this will be a good solution. I wish this was all metal, but maybe for safety they thought plastic will make it easy, but we will see if it connect and disconnect high current that I'm going to test. Length of this is 73.6 millimeters or 2.89 inches. The width is 1.9 inch or 48.5 millimeters. You need about 46 millimeters or 1.8 inch. I'm using this 4-gauge wire. I purchased them from Amazon, 25-foot red and 25-foot black. The link is below the video. Purchased this kit of these connectors. I use them all. I will provide you the link. The link is below the video. Also they are sold like this. With this type. When you're connecting it to the breaker, this is 5/16 with a 4-gauge wire. On the other side depends on your battery. So if you have larger connector for the terminal, use different connector. To crimp these wires with the connector, you need a crimp tool, something like this. I purchased this also from Amazon. The link is below the video if you want to get it. But you can also solder this. If you want to solder it, soldering is a little hard, but it is a best choice, a better option, because you will get a very solid connection. And here my batteries are ready. 4 batteries. These are lithium iron phosphate and each is 100 ampere hour. So I connected them in parallel in order to demonstrate this with maximum current. I have this 4 gauge wire ready. This is now connected to the battery, and this is going to my load. Let's connect this. Let's also connect. So I'm tightening this with this tool. I'm not, wow, it's holding, but I don't know if I can tighten it too much. So not tightened properly. Now let's just check the voltage connectivity and disconnectivity. So when I disconnect it, you see the voltage. I'm reading the voltage after this connector here. So let's just connect it. So that makes it very easy to click disconnect and just push back, and it will connect. So the current is now set to 240 ampere, and once I turn this on, you will see the voltage, which means this is turned on, and also you will see the current. Where is it? In here. Turn it on, 240 ampere. So that's 233, and let's see how many seconds. So turned off, and so this is for protection, and that was the amount of time in the timer. Now let's set it to 200. Perhaps once we set it to different values. Now let's turn it on. It's set to 200. And the countdown continues. Let's see how many seconds, because this is protecting the ignition. Turned off. So that was the time for the 200 ampere. Let's change it to 150. Let's turn it on with 150. Keep in mind that once you turn it on after the previous shut off, still it is warm, so it might affect the result, but my room is very cool, so let's turn it on. 150 ampere, as you can see, and it is on until it turns off. Let's see. I'm putting the timer here so you can see it. So this should take a little longer than 200 ampere and 250 ampere. So that was the time for 150 ampere. Now I set it to 100, even though it's hot a little. The terminals are a little warm. So 100 ampere. So this is my battery voltage. It is on. It should be longer. Because the current is very low, so this is how it protects the ignition. So, turned off. And then it will turn on again if you wait for this to cool down. You see, quickly turned on back. So if you notice now at 100 ampere, it did not release it. It just turned it off. So let me show you again. Now, as you can see, it is 100 ampere. And let's just wait and see when this is turned off and the current turns off, but it doesn't release fully. You see it is turned off. The current is also 0, but this has not been released. Turned on, connected back. Turn on and off quickly. Now I set the current to 100 ampere. It is off. Let me turn it on. So it's not even connecting. This is too hot. I'll use this Seek thermal camera. The link for the camera is below the video. Let me show you the thermal image. So this point, let's see where is my finger. So this spot is 51 degrees in here, so it's okay, 51, but now this becomes harder, which means it is ready to be clicked. It doesn't look hot. Only one terminal, two terminal, these two spots are the hottest. Now turned on again. Let me show you the back side. So let's see if this side is, as you can see, the load is now off. There is no current. Oh, there is 100 ampere at the moment. So let me put the thermal camera and see. So 80 degrees Celsius, 78 degrees. There is a current going at the moment. So the back side is getting hot, but this is not that hot, so it's, I believe, okay. Let me change this to 80. So I've set the current to 80. Let me turn it on. So it needs full click. Until it clicks, there is no connection. So 80 ampere is going, and that's the voltage after the breaker. So we can see the voltage, which means there is a connection. Let's see how long it holds the 80 ampere. So I heard small bump. So the breaker disconnected it and current is now 0 because the voltage is also 0. Now connected back because this will heat up, disconnect and connect back. Now 80 ampere it cannot handle. So let's turn it off. Let me change it to 60. Now I've set it to 60 ampere. Let's turn it on. You see it doesn't go now because it was heat up so much internally. So this now connected, yes. So 60 ampere is going. Let's see how long this holds. So for holding 60 ampere, let's check the thermal image. 49 degrees, one terminal on this side, and 46 degrees the other terminal. So that's okay. Now I changed it to Fahrenheit. As you can see, this terminal is 122, and the other terminal is also 119. 60 ampere is holding. It can handle up to 60 ampere. I've now connected my load and also my clamp meter. We are reading the current here, but the actual correct lab equipment is connected in here, so we can see the 3.35 volt is the battery. But for us the current is important because that's what passes through the switch. So first, the current is now 0. Let's just disconnect it. And as you can see, this is turned off. And let me turn it on. So when it clicks, it gives you the voltage. Let me turn on the current. Let me set it to 200 ampere. That is maximum. The current is set now to 200 ampere, as you can see, and that is the current that you're reading, 199.99. And here's my conclusion. I've tested this with starting with 200 ampere because I was worried that this might burn, because from the face and look and the terminals I realized that this was not made for 200 or 300. So I went with 200. Immediately after a few seconds the breaker disconnected it, which is a good feature. And then I went for 100 ampere. It just lasted a little longer, 15 seconds, and got disconnected. 80 ampere also got disconnected. Only 60 ampere have been holding for about 2 minutes so far, and a thermal image showed that this is not heating up at the moment at the back. It's also cool. This voltage is after the switch. This cannot be used for any current above 50 ampere continuous, because the 6 ampere that I'm using is just the edge between 60 and 80. So to be safe, this can be used only, the 300 version can be used with 50 ampere continuous load. Thank you for watching. If you learned something and found this useful, please thumb up and also subscribe to my channel. I appreciate it. Post a comment or question below. It's really appreciated. If you want to purchase any of this equipment that I used, the link or below the video. I will get paid a commission when you purchase them. Hi, welcome to product review by watthour. In this video we are going to do the review and test of this 1500 watt boost converter with the input of 10 to 60 volts and output of 12 to 90 volts. We are going to test it with 90 volts, 1.5 kilowatt, 1500 watts, and also I'm gonna show you the efficiency at 1500 watt and lower it, and also I'm gonna change the input voltage to 50 volts, input of 36 volts, input of 24 volts, and up to 12 volts. We are going to test it and we'll show you the efficiency.